What is up, Algebra 1? This is lesson 75, and our objective is how do you factor a trinomial with a equals to 1, or when a is not equal to 1. So remember, we've worked with this earlier when a is equal to 1, and your first four in your homework are actually just practicing that. And you should already have this in your quick reference, so you can reference that whenever you're on a quiz. That's just about getting signs of your sets of parentheses. Remember, this is the opposite of FOILing. So we're going to find factors of a there. Remember, this is just a 1 there in front. So I need to find factors of 72 that add up to 17. In this case, negative 17. So remember, they're both going to be negative. So everyone can get that far. A and their both signs are negatives. So now I just need to find factors of 72. So I have 1 and 72. I got 2 and 36. 3 and 24. 4 and 18, 5, no, 6 and 12, 7, no, 8, and 9. So notice my pattern there, I always start with a 1 and 72, like 1 whatever number. Then I work up here, like trying 2, 3, 4, 5, 6, 7, 8. Etc. And as these go up, notice these ones get smaller. And notice as I've reached, these numbers have kind of reached each other, and I've checked all of them in between. In this case, there are none in between, but sometimes you have like, I don't know, 7 and 10. So you have to check 8 and 9 in between them. So I'm just trying to find some of them that will add up to 17. And I'm noticing here this 8 and the 9 will add to 17. So that's going to be the set I want. So I'm going to say 8 and 9. And if you wanted to check, you could FOIL, right? But let's try another one, just because we're trying to save time, because this is what we already know how to do. So I need to find factors of 48 that subtract to give me 2. And we already checked 7 wouldn't factor into that. And again, happens that those last two are going to work. So I'm going to have x and x. I'm going to have a plus and a minus, because I'm in this category here. I have different signs. That last one is a negative. So then I know that I want it to be a positive 2, so I know positive 8 minus 6 will give me that positive 2 that I want. Alright, now it gets a little bit more complicated whenever we start adding numbers in front of that squared term, like here and here. So we're still going to come up with the same basic concept here, as these are going to be what I'm calling x terms, or in this case n terms. And these over here are what we call constant terms. I'm going to use red and blue as factors of those. So this first one is a prime number. We just have 1 and 7 are the only factors of 7. But with 10, we have several. We have 1 and 10 and 2 and 5. Okay, so we have two different sets. So I'm going to say 1 and 10. Now, because what we're going to be doing, and I'll explain this more in a second, we're also going to want the 10 and the 1. I'm going to go ahead and write 2 and 5 and 5 and 2. I'm just going to rewrite this one here, 1 and 7, 1 and 7, 1 and 7. So notice these red ones here are factors of this a, the numbers by the squared. These are factors, and the reverse order of the factors of the constant term, the number on the far right. And so I've just paired up, so there's a 1 and 7 with each of these. Now if there's more options of these, this could get long, and especially whenever there's more options of this and of this, and you'll see that in a minute. So how we're going to do this is, since this last one is a plus sign, I'm going to multiply the outside ones and multiply the inside ones. I'm going to add those two numbers. So 1 times the 10 is equal to 10. I'm going to add to it 7 times 1, which is 7. That comes out to be 17. I'm looking for just the number, not necessarily the sign at this point. So notice I got 17, not negative 19, or 19, so that's not my option. So multiply the outside ones, 1 times 1, which is 1. And then the inside ones, 7 times 10, which is 70. That comes out to be 71. Again, not the option I'm looking for, so I'm going to cross those off. 1 times 5 is 5. 7 times 2 is 14. 5 plus 14 is going to be 19, and dun, 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 that is the number I'm wanting, is that 19. So now I'm going to go back to what we already know. I'm going to draw two sets of parentheses. I'm going to write an N and an N. Since this last sign here is a positive, I know they're both going to be the same, and since that one's a negative, I know they're both going to be negative. Now notice here, these numbers, let me go and just maybe highlight this as the set that I want. So as these numbers came from the ends, so that means these numbers are going to go back by the ends. So notice the one on the left, I'm going to put them on the left, the one on the right, I'm going to put them on the right. So this is going to be a 1 and a 7. So again, this went here and here. And the numbers on the right, I'm going to put in the same order, 2 and 5. So this and this came here and here. Again, we can FOIL to check that. So first, let me get back to a pen here. It's going to be 7n squared outer minus 5n inner minus 14n last plus 10. When you add those two, you get that negative 19n, which is what we're looking for. So this does check out. So my answer is going to be, notice I'm just going to say n minus 2, 7n minus 5. So notice I just didn't write that 1 in front of it here, because 1 times n is just the same thing as n. Alright, do you feel overwhelmed? Take a deep breath, let's try it again. Here we go, factors of that 5 are simply just 1 and 5. Let's look at factors of 18. Now just for simplicity's sake, I have 1 and 18, 2 and 9, 3 and 6, 4 doesn't, 5 doesn't. So those are my options. So I'm going to say 1 and 18, 18 and 1, 2 and 9, 9 and 2, 3 and 6, 6 and 3. And this is just going to stay the same. 1, 5, 1, 5, 1, 5, 1, 5, 1, 5. My 5 keeps getting uglier and uglier and uglier. Alright, so some people might ask, how come you switch these numbers and not those numbers? You could flip both of them and just end up twice as long, and you end up with repeats in numbers. So it's kind of unnecessary work. So I just leave the red ones the same and switch these ones. But it's kind of up to you. You can experiment with that and see how it works. And if you look online, there's other methods of doing that. Doing this as well. I like this method because somewhere in this mess is my answer. So if you want to look up and find a different way to do that, feel free to do so as well. Follow their steps and feel completely comfortable doing that. Alright, so now at this point we have a negative sign, so instead of adding them like we did here, notice we added them. Now we're going to subtract them, so I'm going to say that product of the outside, which is equal to 18, I'm going to subtract now the product of the inside, which is 5, that comes out to be 13. So, not that one, because I'm looking for 27. Outside, 1 minus 90. I don't even know what that comes out to be, but I know it's not going to be 27. So I'm going to cross those out. This is going to come out to be 9 minus 10. Negative 1, so no. Outside, this is going to give me 2 minus 35. Negative 33. Nope. Sum this gives me 6 minus 15, that gives me 9. Again, no. And this gives me 3 minus 30, which gives me that 27 that I'm looking for. Woo, woo, woo. Alright, so then that was an alarm. That was you're just working this out here. So this is an R. and an r. I'm going to have one's a plus and one's a minus. I'm going to plug in these numbers 1 and 5, and we should again highlight here. We're going with this set right here because that's the one that worked out because it gave me that 27, which matches that 27. And then I'm going to plug in that 6 and 3. Now with these, you please check and make sure that you check these, unless you can logically figure it out, but because sometimes the signs that we put in here, notice I just randomly picked the plus and the minus sign. Sometimes I pick them right, but not always. So let's just kind of make sure that we check this out here. First, it's going to be 5r squared outer minus 3r inner plus 30r last minus 18. And these two do add together to give me positive 27r. But if they'd come out to be a negative 27, right, if this had been positive, that would have been negative, then all I would have needed to do is switch the positive and negative signs, and then it would have worked out. So yes, indeed, I did get my answer right. I'm going to say r plus 6, 5r minus 3.